options, and y'all check to make sure. I think everybody is good. And I turn on my video. The reason I don't like to turn my video on is because it messes up the video. It puts me in the video with y'all, and that messes it up. That's why I don't turn mine on sometimes. I can see y'all better when I'm not in there. Anyway, let me try one thing right quick. Meeting options. Yeah, I've already done that. So it still puts me in there and it messes it up. But anyway, eText 9.2. And y'all should be seeing my screen okay. I'm getting there. I don't know why it's taking so long. 9.2. I just want to cover the reciprocal identities and show you that you are responsible for those. So let me find the reciprocal identities and the Pythagorean identities. There's the reciprocal identities, so I'm going to stop right here and let you write those down. Of course, if you printed out that sheet, you don't have to write it down because, and you can remember them just like this. I'll show you another way to remember them, and you don't have to memorize them. Sine, cosine, tangent, cotangent, secant, and cosecant. And you know that the sine and the cosecant are reciprocals of each other, and these are reciprocals of each other. So you know that the tangent is equal to 1 over the cosine. And you know the sine is equal to 1 over the cosecant. And if you do it that way, you don't have to memorize it. Sine is equal to 1 over the cosecant. The tangent is equal to 1 over the cotangent. Oh, sorry, not cosine, cosecant. And the cosecant, what is the cosecant equal to? It's equal to 1 over the sine. And the secant is equal to 1 over the cosine. And the cotangent is equal to 1 over the tangent. And the cosine is equal to 1 over the secant. So I hope, you don't have to memorize those. You just do it like that. That's why I tell students to make sure you do it vertically all the time. Because if you do it vertically, it's easier to see the reciprocals of each other. And that's just something that I was brought up when my teachers at Clemson and Tri-County were showing me how to do this. They kind of did it vertically because it's easier to understand. You do it however you want to. Some people like doing it like this. Sine, cosecant, cosine, secant, and tangent, cotangent. Some people like doing it that way. I don't. I like doing it this way. And you can also remember Oscar had a hunk of apple, apple of, hunk a, hunk of. Okay, so that's your reciprocal identities. So that's your first set of identities that you need to learn. Your second set of identities is the Pythagorean identities. And where are they? There's all students take calculus. So if you want to remember all students take calculus, there it is. All students take calculus. Of course, they don't put that because that's not sophisticated enough. So they do all sine and cosecant, tangent and cotangent, cosine, and secant. And the reciprocal should be on this page. Nope. They're getting there, though. Pythagorean identities. There we go. Write those down. Now, I'm going to go ahead and tell you right now, if you don't learn these, you're going to be in trouble. So make sure you write those down. I don't have any particular secret or easy way to remember. You just need to know them. Okay? So make sure you write those down. I'm going to give you a second to write those, finish writing them. I still see people looking up to the screen, so that means you're writing them. Okay. I still see a couple of people writing. All right. Now, I'm not going to ask you any questions. The only thing I would ask you on this test is solve for the cosine, solve for the tangent, and solve for the cotangent. And all you got to do is use algebra there. I'm not going to, that's what they're doing right here. I'm not going to do that. Make sure you write down the quotient identities. And these right here are very important when you're starting to take apart a problem, because some of you might have been taught that the first thing you do in identities, the first thing you do with identities, get everything in terms of what?
Sine.
Sine and what?
Cosine.
Okay, now in Unit 2, this is all we're going to be doing. And these reciprocal identities, the reciprocal identities, the Pythagorean identities, and the quotient identities, those are going to be helpful in putting everything in terms of sine and cosine. See, tangent is in sine over cosine, and then flip it. Cosine over sine is cotangent. And the only thing I can tell you there is, remember, the tangent comes first before the cotangent. And the tangent is equal to sine over the cosine. And then the cotangent is equal to cosine over sine. And that's the way I remember it. Tangent comes first. So tangent is sine over cosine, and then you flip it. Now, I can tell you right now, I'm not going to test you a lot on the, identities right now. That's coming in Unit 2. But I will do this one, and I'll show you 2 ways to do it. Example 7, and this is a test question. I want you to look at that question right there, and I want you to write it down. This is a test question. It says find cosine and sine if tan equals 4/3 and you're in quadrant 3. Okay, what did I tell you was the first rule of trigonometry? If you ever get confused, what's the first rule of trigonometry? Find out where you what?
Where you are.
Find out where you are. I'm going to put that in red right here because let's say you have no clue how to do this problem. Okay? Find out where you are. Okay? So I'm going to draw me a... If that phone rings again, I'm going to have to answer it. Okay? Tangent theta, because I think it's the person. Yep, there it goes. Hold on just a second. I have to answer this. I'm sorry about that. I've got two things going on with my mother. One, I'm getting her a new cell phone, and two, I'm getting her direct hooked up instead of cable, and I've got people calling me left and right, so I'm sorry about that. All right, so anyway, tangent, Oscar had a hunk of what? Of apple. So the 4 is opposite the 3, so they're both quadrant what? They're both quadrant 3, so that means the opposite is -4, and the adjacent is what? -3. So I just found out where I was. So what can we use now to find the hypotenuse?
The Pythagorean
Pythagorean theorem.
Pythagorean theorem. And that's -3 squared plus -4 squared is equal to C. And that's going to be 9 plus 16 is equal to C. And that's going to be 25. And C is equal to 5. What is sine? Oscar had a hunk. Oscar had, this is opposite, this is adjacent, this is H. So that's going to be -4 over 5. And this is going to be -3 over 5. And you're done. Now, I just did that without an identity. I didn't do any identities on this. And this is the way you do it with an identity. Now, somebody tell me which way you'd rather do it.
The first way?
Isn't it a whole lot easier to do it the way I showed you? Now, I'm going to let you look at that, and you can write it down. This is page number, I can't see the page. Hold on.
635.
Thank you. I don't know why. Oh, I got it. 635. Thank you. You can write that down. I'm going to let you write it down. And you can do it that way. But I have found that the easiest way to do it is just find out what? Find out where you are. Okay? The reason I don't show this is sometimes I think this can be a little bit more confusing to students. Now, once you do this way a couple of 3 times, then you go back here and you can understand how you're doing this. Capiche?
Capiche.
Thank you. So, Mr. Nicholson, are you part of the generation where Steve left us on Blue's Clues? Are you part of that generation?
Yeah.
Yes, I'm a 93 baby, so I grew up watching Steve, and then they replaced him with Crappy Joe.
I don't even acknowledge the other two. I watched them with my kids. The other two, they were imposters.
Absolutely.
Steve just left, man. Do you know why Steve left? He wasn't on cocaine. He wasn't on a band. He wasn't.
He went to
you know why he
college.
left?
He went to college.
For 20 years?
His hairline was receding.
I heard that he left because he joined the military and he was running Black Ops.
I heard that theory too.
No, he actually did an interview. You have to find the interview, and his hairline was receding, and that was going to be hard to explain because he's supposed to be a kid, right? He's supposed to be a kid, in the show, and that was going to be hard to explain to children. Why? Because like Caillou never grew any hair. I never understood that with Caillou. So I knew something was wrong with Caillou from the get-go. Even he was a spoiled brat.
Theory that Caillou can't.
Caillou, there was something wrong with that kid. I didn't let my kids watch Caillou because he was a spoiled brat. Anyway, and there was something wrong with him, and they wasn't truthful. And the Teletubbies, no, Teletubbies were illegal. The Teletubbies and the Wiggles, they were illegal in my house. We watched Blue's Clues and SpongeBob.
They said Caillou was 5'11".
Was what?
5'11".
There was something wrong with Caillou. He had issues, medication, or something. There was something wrong with that kid.
I never knew a kid to be 5'11". That was crazy.
Yeah, that's true. I guess he looked like Charlie Brown too, and I didn't like Charlie Brown when I was a kid. So, all right, let's move on before somebody bitches. Okay, so there's another one. This is another one right here, but this is just solve. I told you I would ask you to solve for cosine. There's an example right there. So make sure you can do this. This is just algebra. I'm not going to go through and do it, but you need to be able to solve the Pythagorean theorem for whatever you need. Okay, I'll blow it up because some of y'all are like squinting. So there you go. Write down that example. That's a test question right there. Solve for cosine. And you just use your algebra, bring the sign over. That'd be a negative sign. And then take the square root of both sides. And the cosine is equal to that. And then you could say secant is equal to 1 over that because of the reciprocal identity. So there's 2 test questions right there on page 265 or 675 or whatever page it was on, 635.
Yeah.
Example 8 is solving a Pythagorean identity for one of the other components. So I either want you to solve for the sine or the cosine. So if I said sine squared theta plus cosine squared theta is equal to 1. So sine squared theta is equal to 1 minus cosine squared theta, and square root of both sides. And I'll show you all this in just a second. 1 minus cosine squared theta. So sine theta is equal to the square root of 1 minus cosine squared theta, and that would be the sine would be the cosecant. The cosecant theta would be 1 over 1 minus cosine squared theta. And this is the other one. There's the other one. So you're either going to solve for the cosine or the sine. And you just bring the cosine over and take the square root of both sides. And you get this. And then if I want the reciprocal, that's that. So make sure you can solve the Pythagorean identities for their components. Make sure you can do that. Now I can tell you right now that the first one I did, that one when I set out, where this one right here, there'll be more of these on the test than these. I'll give you 2 or 3 of these, and I'll just give you like one of those. That's kind of the way I do the Pythagorean identities. I'd give you 2 or 3 of these, and I'll give you one of those. Comprende? Comprendo, whatever. I done forgot what Miss Hernandez told me to say. Comprenda, comprende, comprendo. Say it one more time, Miss Hernandez. When you're addressing a group, is it comprenda or comprendo or comprende?
Comprenden.
Comprende. Okay, thank you.
It's like D. Like
It's what?
D. It's like it ends in DEN, so comprenden.
Yeah, that's right. Comprende. How do you spell it? Comprende. Is it DEN? Comprenden?
Let me check.
What'd she say?
I think it's COMPREDEN.
DEN. Comprenden. That gum, Mr. Nicholson knows that Española. I hear you, bud. All right, so let's move on. I tell you what, I tell my son, Daddy, of course, he don't listen to me because daddies are stupid. But I still tell him, I say 2 subjects, and tell my advisees this too. 2 subjects, you take all the courses you can take. Psychology, so you can find crazy people before you meet them. And 2, Spanish. Because if you can understand one foreign language, you can understand other foreign languages. And since they don't teach Latin anymore, Latin is the best one because you can figure out your way through all of them through Latin. But anyway, I'll shut up. Next page. Yeah, you got to take all the psychology courses because most of y'all are going to have a relationship either personally or in your field, and you got to find the crazy people. And they will give you indicators, like wearing sunglasses inside. That's an indicator. All right. This is an application. This is R cosine theta, R sine theta. This is just a application. I'm not going to spend a lot of time on this. Pythagorean theorem. I'm not going to spend a lot of time on that. So y'all can read that definition. I mean, read that one if you want to. And I'm going to move on to 9.3. If I can ever get there. Let me make this small, please. There we go. 9.3, right triangles. Now look at what they said. Now they say opposite. Oscar had a hunk of apple. Now see, to me, this is redundant. And I don't really think that, I don't really know why they do this, but they do. So instead of teaching just one unit or one section, they break one section up into two. I don't agree with that, but here's an example right here. So we're going to, there you go right there. I'm going to, well, let me do this and pull this in. And there you go. I mean, it's not hard. It says the length, opposite side of angle A. So I'm going to draw angle A right here. I'm going to put little man right there. Opposite is 7. Let's see. Okay, the opposite up here. Sorry. Okay, so erase this guy. The opposite is 7. The adjacent is 24. And the hypotenuse is 25. Okay? And they want to know sine, cosine, tan. I'm just going to do the first 3. So this over here is the opposite. This over here is the adjacent. And this over here is the hypotenuse. Oscar had a hunk of apple. Oscar be 7 over 25. 24 over 25. And 24 over 7. Now, what they're doing is they're changing the little man. See, the little man used to be down here. And in this section, they're putting him up here. Does everybody understand that? That's basically the difference between the two sections. All right, let's look at this one. I'm just going through and picking some that might be test questions. Okay, now remember, 60 degrees, we already talked about this. 60 degrees is a special angle. 60 degrees looks like this. And it's 1, 2, square root of 3. And the angle is right here. So your little man is right here. So that means that's opposite, that's adjacent, and that's hypotenuse. Sine, cosine, tan. Oscar had a hunk of apple. Oscar, square root of 3 over 2. Cosine, adjacent, 1 over 2. And square root of 3 over 1. And that should be your first 3. Square root of 3 over 2. 1/2, and square root of 3. Now, we've already covered this, so it should be like, oh, yeah, I remember that. There's your special angles. There's your 45. 1 square root of 2. So let's do 45. And we already did it, but we're going to do it again. This is 30 degrees. $45. 1 square root of 2. Opposite. I'm sorry, adjacent. Hypotenuse. Sine. Cosine. Tan. Oscar. Had. A. Hump. Of. Apple. Oscar, 1 over square root of 2. Square root of 2 over 2. 1 over square root of 2. Square root of 2 over 2. And opposite, 1 over 1 is 1. Take it to your handy dandy special angle chart. 45, square root of 2 over 2, square root of 2 over 2, and 1. 60 degrees. And that's 45. 60 degrees. 30 degrees. 1, square root of 3, 2, sine, cosine, tan, Oscar, had, a, hunk, of, apple. Little man's down here because it's 30 degrees. So that's your adjacent, that's your hypotenuse, that's your opposite. Oscar, had, 1/2. Square root of 3 over 2. And 1 over square root of 3, which is the square root of 3. Let's see. That'd be 1 over square root of 3 multiplied by the square root of 3 over the square root of 3, which is equal to the square root of 3 over 3. So go to the card. 30 degrees, 1/2. Square root of 3 over 2. Square root of 3 over 3. And so on. So remember your special angles, because you're going to use them to make up your unit. They're going to show you the unit circle, I think, coming up. And of course, I already showed you how to do the unit circle. I don't go over the cofunctions. You can write those down. They're also on that cheat sheet that I sent you that nobody printed out. You can write those down. I'm going to leave them right there for you. That's why I sent you the identity sheet, so you wouldn't have to write everything down. You're welcome. Give everybody another minute or two. I don't use these very often. I don't test on them either. The calculator has pretty much taken care of the cofunction identities. All right, like I say, those are on that sheet, so I'm going to move on. Yep, they're fixing it. They're fixing to show you the unit circle. That's what they're getting you ready for now. So I've already shown you the unit circle, so we'll just probably go to that here in just a second. There's a good one. I like that one. Let's do this one. All right, I'm going to let y'all write that one down. Find the functions for 210 degrees. Now, first of all, you need to find out where you are. Find out where you are. Use 210 degrees to figure out if you're dealing with a 90-degree angle or a 60-degree angle or a 30-degree angle or a what? 45-degree angle. So that means I'm going to draw a cross. And I know 210, this is 90, this is 0, this is 360, 270, 180. 180 is what? I mean, 210 is what? What is 210 degrees? I was hoping somebody would see it right here and say it out loud.
It's in the
What is
third
it?
quadrant.
180 plus what? 30. I want you to find me the sine, cosine, and tangent of that 30-degree angle. Sorry about that. Okay. So there's the, notice, what did I do? I put a negative there and a negative here, and the hypotenuse is always positive. So sine, cosine, tangent. And I'm going to go away from what I usually do. cotangent, secant, and what? Cosecant. Oscar had a hunk of apple of hunk A had Oscar. Okay, somebody tell me, all students take calculus. So what's going to be positive? Somebody tell me what's going to be positive. That would be the tangent and the cotangent, Hubert. Thank you, class. Thank you for the communications. You suck. All right, so that means the rest of them are going to be negative. Right? Because all students take calculus, tangent and cotangent is positive. Oh, y'all settle down, please. Mr. Bradley, you're disturbing the rest of the class. And he just sits there. It's a joke, Mr. Bradley. You're supposed to smile a little bit. I don't think he can hear me. Oh, me. So here's the opposite. They hate me. These students hate me, Mr. Nicholson. They hate me.
I don't know what their problem is. I'm going to speak up.
I don't understand it. I really don't. Miss Davis, why do these students hate me?
I don't know. I don't hate you though.
Okay, thank you. I appreciate it.
Yeah, I don't hate you, Mr. McCoy.
Okay, thank you, man. I appreciate it. I won't have to put smokestacks on my pickup truck now. All right. So anyway, Oscar had. Oscar is -1 over negative, or what is started? Sorry, 2. I can't talk. Adjacent is the square root of negative. That's negative square root of 3 over 2. -1 over -3, which is going to be the square root of 3 over 3, and it's positive. And that means this is going to be -2. And this is going to be -2 over the square root of 3, which is equal to 2 square root of 3 over 3, negative. And this is going to be square root of 3, be a positive square root of 3. And that should be everything. Now, did y'all notice something? I didn't memorize anything. Let's go look and see if I got it right, and I didn't memorize anything. So for the sine of 210, I got -1/2. Look at there. Cosine, negative square root of 3 over 2. Tangent, square root of 3 over 3. Cosecant, -2. Secant, 2 square root of 3 over 3, negative. And look at there, it's a miracle. I didn't memorize a single thing, and I got those angles correct. Makes you wonder why you were told to memorize. Now, there's nothing wrong with taking this and learning it and then eventually memorizing it, but now you know how to get it. That's the main thing. You don't know how to get it and you memorizing it. People don't want to memorize what they don't understand. Now that you understand it, because it's over here in this third quadrant, now you know why they're negatives. And you should feel good about yourself. So you don't have to put on too much makeup and have an orange face and a white neck. Ladies, that's not good. Guys, run in the other direction. It's called Oompa Loompas. You ever seen an Oompa Loompa? Run. Run in the other direction. Miss Nicholson, you ever seen an Oompa Loompa? Orange face and a white neck?
I have dated an Oompa Loompa.
Oh, they are crazy. All right. Let's see what else. Okay, now I might give you one or two of these on the calculator. I mean, on the test, and if you miss it, please don't tell anybody. Okay? Make sure you can do these 4 on your calculator, because I will give you one of these on the test. Please do not tell anybody if you miss it. I'm not going to go through that because I think you should be able to do that on your calculator, and I shouldn't have to show you. But if you need me to show you, send me a question and I'll show you. And the rest of the class will make fun of you while you're not looking. Okay? I don't know why they haven't showed you how to do the unit circle yet. Okay, find an angle of measure. What does this say? This says find the angle of which 300-pound car resistance. That's an application. I'm still trying to find the unit circle, but I guess they're not going to show it to you. Nope. So it must be in 9.4. Let's see what 9.4 has to offer. This just continued applications of angle of elevation. Now that's what we talked about before. At the beginning of class, I told you that there were 2 types of elevation. These are practical applications. These are bearings and distances. We'll get onto that later. Okay, so what I want everybody to do for homework, I want everybody to work on 9.3 and make sure you send plenty of questions. I'm not going to go into 9.4, but we are dealing with direction. Now this is where, now I will tell you that I have been known to put a lot of 9.4 on the test. Okay, because it's bearings and distances. So I have been being the surveyor, being the surveying background, I do a lot of this on the test. So I'll go ahead and show you a couple. A bearing, I'll go ahead and tell you right now, what is a bearing? And this will be what you can. A bearing is off of true north or south. Okay? If I tell you that I'm going south 23 degrees west, then that bearing is south 23, it's southeast. This is south 23 degrees east. This angle right here is 23 degrees. If I tell you northeast 45 degrees, it's 45 degrees right here, and that's north 45 degrees east. These 2 lines right here are bearings. Now, I may get in trouble with academia because they want a true bearing is off of north, but in the real world, these 2 lines right here are bearings. The first one is off of north. The second one is off of south. Bearings are measured off of north and south. So I can do this one over here. Let's say this is 15 degrees. Then that would be south 15 degrees west. $70 degrees. North 70 degrees west. So you can do bearings off of north, or you can do bearings off of north and south. And in the real world, they're off of north and south. Now, why am I showing you these bearings? Because between the green lines, what is this called? It's called an angle. And between the pink lines is called what? An angle. And now you're going to find the angle between the bearings. How do you do that? Well, this angle right here, somebody tell me what's between north and south. What's that yellow line, the yellow angle right there? Straight line, what is it?
180 degrees.
180 degrees. So if I want to find the purple angle, I take 180 degrees and I subtract as soon as I can find my black pen, which I have lost. Y'all have to excuse me. I'm very persnickety about my colors. Minus parentheses what? My 45 degree angle. Where's my green now? 45 degrees plus 23 degrees. And that will give me my purple angle. So, take my handy dandy calculator, and I'm just going to do this for, for time purposes. 180 degrees, second app, degrees, minus parentheses. Well, I'm just going to say, what, 68 degrees? 68 degrees. Is equal to 112 degrees. So, I just lost the purple one. What did I do with the purple one? I just pulled it out. I'm losing my mind. All right. So the purple angle is 112 degrees. All right. Now you do the orange angle. You do the orange angle. And remember, this angle right here is 180 degrees. So that's going to be 180 minus 70 degrees. So my pink pen that I can't find, 70 degrees plus 15 degrees. And that's going to be 180 minus 85 degrees is what, 95 degrees?
Ninety-five
180,
degrees.
would it be 95? What?
95 degrees.
Okay, so 95 degrees is equal to that. So that's where we're going with 9.4. We're going to be going to bearings and distances. And you're going to be using Pythagorean, and you're going to be using the trigonometric values to do this right here. Okay? Let me just show you right quick. If I pull a distance right here, that's a 90-degree angle. If I pull a distance here, true east or true north, that's 90 degrees right there. This right here is 90 degrees. And this right here is 90 degrees. So you're going to see how this applies in 9.4. All right? Okay, let me stop right there and stop the presentation and stop the recording.